have your own electron houses out because today we're going to go to the Electron House party. There are 3 rules for electrons coming to an Electron House party. Rule number 1, electrons are lazy. This rule supersedes every other rule. So we're going to see 2 more, but above all, electrons are lazy. Electrons are a lot like people. They don't want to do any extra work if they don't have to. Now, when I say electrons are lazy, what do we mean in chemistry talk? Well, we mean that electrons want to fill in the lowest energy orbitals, the lowest energy slots available to them before any higher energy levels will be filled. All of nature follows these laws, by the way. That's why if I pick up this tape and I put it at a higher energy state, when I release it, it's not a mystery what will happen. It's going to fall down because that's a lower energy state. There's never a time when the tape flies up into outer space. That would be very unexpected. So the higher I lift this, it's a higher potential energy state. Imagine this like the electron. The further from the nucleus the electron is, it's like the higher I've lifted the tape. So electrons want to slot in the lowest energy possible first. So electrons are lazy, and in chemistry speak, we call this the Aufbau principle. This is just a German word that means to build up. So it means to build up from the lowest energy to the highest energy, Aufbau principle. So I'm the first electron arriving to the Electron House party. So you're here to greet your first electron guest, and you're like, hey, welcome to the Electron House party. And the electron's like, sorry I'm late, didn't want to come. I'm pretty tired, so I'm just gonna crash if you don't mind. You're like, yeah, sure, the bedroom's right here. Now the first electron has all these choices, but remember, it's lazy. So when it walks through the door, it barely wanted to do that. So when it shows up, it's gonna go right into the S bedroom on the first floor and crash in this bed. We're gonna use a little half arrow to represent electrons here. So the first electron arrives, it goes to the first floor of our house in the S bedroom in the S bed. Now, once more electrons begin arriving, rule 2 kicks in. So rule 2 of Electron House party is this. Electrons hate each other. So rule 2 of Electron House parties, electrons hate each other. Now, they're still lazy though. So they hate each other, but above that they're lazy. And weird thing, they all hate each other, but they're all exactly identical. Every electron in the universe is exactly the same. Same amount of charge, same mass. So the second electron shows up now. And you're like, oh, wow, another electron in my Electron House party. And the second electron's like, I see there's another electron here. Lame. You're like, yeah, this is an Electron House party. Fine, whatever, I'm gonna crash. So remember, it's lazy. So it shows up, it wants to crash, it comes to the S bedroom on the first floor, but there's already an electron here. Now, as a choice, there's plenty of room in this bed for one more electron to just crash. They're not gonna get near each other, they hate each other, but there's room, they could crash and make it work. Or this electron would have to walk upstairs? Nah, remember rule 1 of Electron House party, electrons are lazy. So it gets here and it's like, hey, you hate me, I hate you, but if we don't share, I'm gonna have to walk up these stairs, open a door, and crawl into another bed. And this electron's like, yes, I hate you, but I also understand and empathize. There's room in here, but no more than this. So the next electron will slot in here. So now we're going to begin to explore rule 3, the final rule of Electron House party. Oh, by the way, the electrons hate each other thing, This has a fancier name that we'll get to here in a moment when we get to the P bedroom upstairs. It's called Hund's rule. So let's start adding some more electrons to our electron house and see what happens. When the third electron arrives, can you guess what might happen? It's going to see that the first floor of the house is occupied, the 1S bedroom is full, and it's going to make its way upstairs, and now it has some choices. It's going to go into the 2S bedroom. At worst, it'll only share with one other electron. If it goes into the 2P bedroom, then it might have to share with as many as 5 other electrons, a total of 6. So the third electron entering is going to go here. Let's say a fourth electron arrives. It's already upset. There's 2 electrons on the first floor already. It's had to climb stairs. It's completely over it. It's had to open a door. And it sees that there's an electron sitting in this bed already. And it's like, hey, I've already climbed up these stairs. I've already opened a door. Don't make me open another door. And this electron's like, fine, I get it, I feel your pain, there's room here, we both know it, you can slot it. Now's where Hund's rule will kick in. Because you see, this is the first time in the P bedroom that we actually have 3 beds available. So with the electrons hate each other, Hund's rule, what do we really mean? Electrons will fill in one at a time before they begin to pair up. Let's see what that looks like in practice. As more electrons begin to arrive, the next logical place for them to go is the P bedroom. So we'll have an electron slot in here. So this is our 1, 2, 3, 4, 5th electron. When the 6th electron comes, it's not going to go here. That would be insane. There are 2 empty beds. So if that 6th electron comes and tries to slot in this bed, electron here is going to be like, bro, there are 2 empty beds. We both hate each other. Please move. So they're going to fill in one at a time first. So the 6th is the 7th electron. Now when the next electron comes in, so 2, 4, 6, 7, the 8th electron total, now we have some choices. So it could walk all the way upstairs, but we know electrons are lazy. At this point, Hund's rule kicks in. Electrons hate each other, and they'll begin pairing up. Now, I said there are 3 rules of Electron House Party. So electrons are lazy, so they want to start at the bottom floor and work their way up. Electrons hate each other, so they're not going to slot in the same bed if there are empty beds available. So you might be asking, what's the 3rd rule? Well, if you noticed anything about how I drew these arrows, one is pointed up and one is pointed down. So if electrons do share a bed, what we call an orbital, they must have opposite spin. Now, I don't have a cute way of remembering this. It's called the Pauli exclusion principle. So the 3rd rule of Electron House Party, so rule number 3 is Pauli exclusion principle. I think that's the right principle, but I don't know for sure. What does it mean? Does opposite have 2 P's? Electrons in the same orbital must have opposite spin. For our purposes in chemistry, we can think of it this way. We know that electrons are negatively charged, so if I bring two negative charges near each other, they'll repel. So the way the electron gets around that is that if one has up spin and one has down spin, they generate a magnetic field that can kind of overcome that repulsive force and allow them to occupy a similar space. That's not entirely true. The real nature of this we discuss in astronomy in much more detail. The real truth is no two bits of matter may ever occupy the same space at the same time in the universe. This is the essence of how stars work, nuclear reactions work, and it's called the Pauli exclusion principle. And that rule is never broken, almost never, except in a black hole. If you want to learn more, take astronomy. So we can continue like this, filling in electrons. The next place we go would be the 3s. Then we go to the 3p, filling in one at a time, following Hund's rule, going back and pairing them up with opposite spin, Pauli exclusion principle. The final note is this. You had to make the D bedroom up here, the 3D, special somehow. What's special about it is there are 1, 2, 3, 4, 5 beds. 10 electrons? Hell no. Electrons don't want to do this. So they hate each other. Remember that. They are lazy, but they hate each other. So the next electron that comes into the third energy level, it sees that the only available bedroom there is the D bedroom, and it might have to share with a total of 10 electrons. It's like, you know what? I already walked up 3 flights of stairs. I'm already mad that there's this many electrons present. I can walk up one more flight of stairs to the S bedroom and fill in here. And that's what the next 2 electrons will do. That's why the D bedroom is special. It gets skipped over. So electrons will fill in the 4s first before the filling in the 3d. Now at this point, the electrons are like, well, I would share with 9 others or 5 others, so what's the difference? Now the 3d will begin filling in. And they go back in with opposite spin, and it continues on like this. Now, this is going to seem really overwhelming. You already have your electron house constructed. I have really good news for you. There exists already another pre-built electron house for you, and it's actually in the exact same order of your electron house, and you'll always have it at your fingertips. Follow me over here and I'll show it to you. It's the periodic table. There's so much information locked up in here that you never knew about. But now you get in on this secret knowledge. You notice the periodic table is in blocks. So here's a skinny little block. We call this block the S block. How many electrons can fit in any S bedroom? 2, because there's only 1 bed. Look how wide the S block is. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Now, the next tallest block over here, we call this the P block. How many beds are in the P bedroom? 3. So how many total electrons can fit in there? 1, 2, 3, 4, 5, 6. Surprise, surprise, the P block is 1, 2, 3, 4, 5, 6 electrons across. This block, can you guess it, is the D block. How many beds are in the D bedroom? 5. How many total electrons would that be? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the final block down here is the F block, which you may know already. There are 7 orbitals. That's the real name for the beds. So that means there should be 14 total electrons. And indeed, there are. These little stars on mine indicate those elements go here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. The periodic table is an electron house. What's the only bedroom available to you on the first floor? S. 1s. Helium goes here. Then where do the electrons go next? 2s. But there's another kind of bedroom on the second floor, the 2p. then we go to the 3s, and so on. I'm going to leave it off here. You're going to pick back up with this on the GPB video. The quantum mechanical model is confusing, and if you're like, Heff, I don't understand anything you just said, you're having the appropriate reaction. It will take a while and practice, but I promise you it will suddenly click and it will become easy. We're going to do a whole lot of practice with this next week, but I wanted to have this introductory video for you to go through and explore your own electron house with an electron house party, and I'll see you back here next time.